Okay, so in this question, a ball starts falling with zero initial velocity on a smooth inclined plane, forming an angle alpha with the horizontal. Okay, having fallen distance h, the ball rebounds elastically off the inclined plane. At what distance from the impact point will the ball rebound for the second time? Okay, so let's say this is the inclined plane. Makes an angle alpha to the horizontal. This is the ball at t equal to 0, and basically drops down, okay, and bounces off elastically, which means that if the velocity over here, just a second, so if the velocity over here is say some v, okay, in that case, so basically this angle is alpha. This picture is of course not according to scale, so this is also alpha. Okay, that is what is elastic collision. So it will like properly get reflected, and if it comes with a velocity v, then the just after the collision with the inclined plane, the ball will have the same magnitude of velocity v, but in this direction. Okay, so I'll again draw just the part after the collision. So basically this is your inclined plane, right? Now after the collision, now this ball has a velocity v, okay, and this whole angle is alpha and alpha 2 alpha, so it is making an angle of 90 degrees minus 2 alpha to the horizontal. Okay, and its trajectory will be something like, after the collision, its trajectory will be something like this. So it will go like this, and it will collide somewhere over here to the inclined plane, and basically this is the distance. Let's call it d, that is required. Okay, now this is the thing, and yeah, of course, this height is h. Height up to is the ball falls before the collision. Okay, so now after the collision happens, we can see that the ball is at an, like, it's similar to throwing a ball at an angle to the horizontal. So it's like projectile, it's a projectile basically. Okay, so and the angle is 90 minus 2 alpha, the projection angle. So we need to find, if we have to find out the distance d, what we can do is, we already, from a previous problem, and this formula is a really important formula to know, that is, if the, like, let's say this is the positive x and the positive y direction, the vertical is the positive y direction, then y is equal to x tan theta minus gx square by 2 u square cos square theta. So this is basically the projectile's trajectory equation, y in terms of x. This is u. Yeah. Okay. Now, if you see, in our case, of course, let's use a different color. So the initial at t equal to 0, the coordinate is 0 comma 0, of course, right? And after hitting the second inclined plane for the second time, what do you think would be the coordinates? So it is very simple. So we consider this, right? So this angle is alpha, this is t cos alpha, and this is t sin alpha. So the coordinates of this point would be since it is in the positive x direction, it is d cos alpha, but it is in the negative y direction, so minus d sin alpha. And since this is also a point on this trajectory, right, so this should satisfy this particular equation. And yeah, I would like to mention that theta is equal to 90 degrees minus 2 alpha, right? U is equal to the velocity, this v. And what is v? So we consider only the motion before the collision. So this is a very small calculation. So before the collision, we just consider the y direction, right? Then so v square minus u square equal to 2as. So v square is basically this v square minus u square. Initial velocity is 0 at t equal to 0 equal to 2. Acceleration is in the negative direction, so minus d, and displacement is also in the negative direction, so minus h. So basically this means your v is equal to root over 2gh, right? So u is equal to also equal to root over 2gh, right? And yeah, this is what we need. So this means this equation becomes y is equal to x tan of 90 minus something is cot. So cot 2 alpha minus g x square by 2 u square is 2gh, and cos square 90 minus 2 alpha, again cos of 90 minus something is sine square 2 alpha, right? Okay. Now we'll substitute basically this over here. Okay, d cos alpha minus d sin alpha. Y is equal to minus d sin alpha, and x is equal to d cos alpha. Alpha minus g sorry g x square. So what is x square? This is d cos alpha, so x square is d square cos square alpha by 4gh times, okay, sine square 2 alpha. Sine 2 alpha is 2 sine alpha cos alpha. So this would become 4 sine square alpha cos square alpha. Cos square alpha cancel out. And one more thing, d d and d, all these d's cancel out. So this means minus sine alpha is equal to cos alpha, right? And write it as cos 2 alpha by sine 2 alpha is 2 sine alpha cos alpha, okay, minus g times d times, okay, and in the denominator becomes 16 gh sine square alpha, okay. So cos alpha and cos alpha cancel out, okay. So this means If we shift this term onto the right and this term to the left, this becomes GD divided by 16 GH sine square alpha is equal to now cos 2 alpha is nothing but cos square alpha minus sine square alpha. So square alpha minus sine square alpha by 2 sin alpha plus sine alpha, right? So now sine square alpha is equal to cos square alpha minus sine square alpha plus 2 sine square alpha by 2 sine alpha, right? So if you see, this becomes cos square alpha plus sine square alpha, which becomes 1. Okay, sine alpha, this cancels out, 2 8. Okay, one thing which I didn't observe earlier is g and g also cancel out. So and this whole numerator, as I told, becomes sine square alpha plus cos square alpha, which becomes 1. Okay, so this basically means d is equal to nothing but 8h sine alpha. Okay, so yeah, basically in order to solve this question, you need to, like, first of all understand that when they're saying rebound elastically, it means it rebounds, it follows the law of reflection essentially. So it rebounds with the same velocity as it was, and as was just before the collision. Magnitude is same. The direction basically follows the laws of reflection, and then it's projectile motion. So for the projectile motion, this formula is really important. Y equal to x tan theta minus dx square by 2u square cos square theta. You just solve for this considering the coordinate of the point of the second collision on this inclined plane, and you just substitute the values of the coordinate because it will satisfy the projectile equation, and there you go, you get the distance between the two collision points. So yeah, that's that. Thank you.